So, again, I do believe you guys have seen the power rule. Okay. So the derivative of derivative of x squared would be 2x. Derivative of x cubed would be 3x squared. Derivative of 4x is 4x cubed. And 5x is 5x to the fifth. So do we see the pattern? Sorry, 5x to the fourth. Do we see the pattern? Yeah. All right, so what's the pattern? Yeah. Bring down the exponent, multiply it by the exponent, and subtract 1 from the exponent. That is the power rule. All right. So, for example, number 1, if we bring down the exponent, we get 37. X, subtract 1 from the exponent, we get 36. Number 2, bring down the exponent, 9, subtract 1, 8. Easy enough, right? Now, there are some cases in which you do need to rewrite your term. So, for example, this can be written as y is equal to x to the negative 1. Then we can do the power rule. Y equals negative x, and we subtract 1 from negative 1, we get negative 2, which gives us y, or y prime here. Y prime is equal to negative 1 over x squared. So, number 4, very similar. We have y is equal to x to the negative 4th. All right. So dy dx, there you go, is equal to, bring down the negative 4, subtract 1. So dy dx is equal to negative 4 over x to the 5th. All right. So square roots can be written as a rational exponent. Y is equal to x to the 1/2. So f prime of x, bring down the 1/2, and then subtract 1. Subtracting 1 from 1/2 is just negative 1/2. F prime of x is 1 over 2 square root of x. Move to the denominator. Negative exponent means it moves to the denominator. If it's in the denominator, it moves to the numerator. So we can write this as y is equal to x to the 3/7. So y prime is equal to 3/7 x to the negative 4/7. Y prime is equal to 3 over 7. 7th root of x to the 4th. Yes. If it was already a negative exponent, then yes, you would bring down a negative, like we did for the first two. But because after for 5 and 6, when you always bring down the original exponent and then subtract. The negative exponent just moves it to the denominator. Now, first thing we probably want to do is we want to simplify this. So how can you simplify x over square root of x? It might be easier if you write it as x to the 1 over x to the 1/2. So how do we divide variables? You subtract the exponents. So x to the 1 over x to the 1/2 is just x to the 1/2. So that means f prime of x would be 1/2 x to the negative 1/2, or 1 over 2 root x. Yep. So f prime is 7. 2 root 7. Now you guys did see the power rule last year, right? This is the power rule. It's actually called the power rule.
Yeah.
Yeah, you're gonna find it's not gonna be just straightforward, easy, you know, integer exponents. And you get caught up.
I feel like I need to do one because I'm like already finished. Correct.
So just give you AP on the homework over the weekend without giving you time in class to get it done.
The homework's not work anyway.
Yeah, they did. It worked today. It was Google's issue, not ours.
But they're not just 7 pages of it's not on me.
Yeah, no, you have plenty of time to get it done.
Why did everybody need more ready for?
Did you grade it and submit it? No, you did.
Oh, so you ready?
Yeah,
What?
yeah. Did the grade it yourself. There should be an option when you're done. Yeah, yeah. When I look at it again. Yeah, if it's not graded, I don't look at it. No. Yeah. That's why I said you guys have to grade this. It is self-graded.
I'm really up.
Huh? Yeah. The idea is that you're seeing the question, seeing the answer, and how it's answered. It tells you the answer when you grade it. Yeah. It's real sad. All right. So f of x is equal to x to the 1/3 times x to the 3rd. Now, when multiplying variables, you add the exponents, and instead of having 3 1/3, we want that as an improper fraction. So that is going to be x to the 10/3.
Excuse me. So hold on. How do you get 10? 1/3 plus 3.
1/3 plus 3 is 3 1/3.
No.
3 is the same thing as 9/3, correct?
Thanks.
F prime of x would bring down the exponent 10/3. And when you subtract 1 from 10/3, you're subtracting 3/3. So what's 10/3 minus 3/3? 7/3. All right. Now you can write that, and it's probably best to write that as 10 cube root of x to the 7 power over 3.
Yeah, it's best to write down.
Now, why is it best to write as the 7 power outside the radical instead of inside? All right. What's 8 to the 7th power?
Big number.
It's a big old number, isn't it? Would it be easier to cube root 8 first and then raise 2 to the 7th power? Yeah. So, f prime of 8 would be 10 times the cube root of 8 to the 7th power over 3. Now, the cube root of 8 is what? 2. And 2 to the 7th power is 128.
That's just the, I did to the,
Yeah. You just keep doubling it until you do it 8 times. 2 times 2 is 2 squared, then times 2 again is cubed, then 2 again, and you keep going until you do it 8 times.
That's the,
It's not gonna do it. I mean, you do have a calculated version of the test, but it's not going to have that. So that gives you 1,280 over 3.
That's approximately. And that's, I can't believe.
No, you can't. Yeah. It cannot be reduced. One ends in 0. But no, it still could be. Do you know how to check to see if you can divide a number by 3? I really don't.
Anything.
What's 1 plus 2 plus 8 plus 0? Take the numbers, add them together. What do you get? Take the numbers, add them together. What do you get? Yeah, it'll work for every. Yeah. So since you cannot divide 11 by 3, you cannot divide this by 3. All right.
My whole perspective is fine.
It works for 9 as well. Yeah. This is something I teach my Algebra 1 kids.
Well, wait, we didn't learn that. Mr. Martin, Super Martin, it's all the one I attention on the brain. Yes. I just like
Yeah.
Violently. I struggle
I mean, you guys weren't taught division rules?
No.
Like, you know how you can divide something by 5, though, right? There you go. So that's good. You know how you can divide by 2? Yeah. 3 and 9 have the same rule. 3 and 9 have the same rule. If you can add the digits up and it's divisible by 3 or 9, then yeah, you can divide the whole thing by 3 or 9. 4, you guys know how you can divide something by 4? Just the last 2 numbers. Just look at the last 2 numbers. You can divide the last 2 numbers by 4. It's like this is divisible by 4 because 80 is divisible by 4. Yeah. 320.
We don't need to copy.
Because you can divide 12 by 4 and 8 by 4. You get 320.
What? I have, yeah,
the last 2 numbers, yeah. You have to look at the last 2 numbers. So if that had been a 2 at the end, then yes, that wouldn't work. All right. The rules for 8 is similar. It's the last 3 numbers for 8. The rule for 6 is if you can divide it by 3 and it's even, you can divide it by 6. 7 has no rule.
No.
7, just put in your calculator. Okay? There's no rules. However, did you know if you take any number divided by 7, it is a repeating decimal of the same 6 numbers, just in different orders?
So.
Yeah.
Yes.
Huh?
So we have no.
It's the number of completion. Yeah.
One lesson a day.
All right. Parallel tangent lines. Now, in order to have parallel tangent lines, the slopes must be what? Must be the same slope. And how do you find slope? F prime of x must equal g prime of x. In order to have the same slope, the derivatives have to be equal to each other. So what's the derivative of x to the 4th? 4x cubed. What's the derivative of x cubed? All right, and then we solve. Subtract 3x squared minus 3x squared. Get 4x cubed minus 3x squared is equal to 0. Factor out an x squared, we get 4x minus 3 is equal to 0. So there's 2 instances where the slopes are the same. One when x is equal to 0, another when x is equal to 3/4.
Cool.
And let's listen.
God. Oh, that one like them.
Derivative rules if. Okay. What is the slope of a constant?
Straight line.
What kind of line? Horizontal line. What's the slope of every horizontal line? So what's the derivative of every constant? 0. Because again, derivatives are given to find slopes. Since constants are just horizontal lines, and horizontal lines always have a slope of 0, derivative of every constant is equal to 0. Derivative of any constant. Now that includes, if I did d dx of pi to the 7th power, that is 0. Because pi is constant. It's an irrational constant, but it's still a constant. Right. This is probably one of the things that tricks people up the most, is because they see an exponent and they go, oh, I can just use power rule. You can't on pi. Okay.
Where I come from. What man?
Now, if you have a constant times, a variable, that is going to be the constant times the derivative. Okay. An example of that, if I have y is equal to 3x to the 4th, when I bring down, it's going to give me y prime is equal to 12x squared. Not squared, cubed. So when you bring down the exponent, you multiply by what's already there. If you have a plus or minus sign in between your terms, you can separate the terms out and do the derivative individually. So this would be du dx plus or minus dv dx. Again, an example, y is equal to 2x squared plus 5x minus 7. Then y prime would be 4x plus 5. You just do the derivative separately. Before you get started on any of these, it would be advisable to rewrite it in terms of actual exponents instead of having a variable in the denominator or a variable in a radical. So for number 1, you may want to rewrite this as y is equal to 2x squared minus 5x to the negative 1 plus 6. Then do the power rule separately. So y prime would equal 4x, well, to the 1, plus, now because it's plus because we brought down a negative exponent, 5x to the negative 2. So bring down the negative 1 to the negative 5 is what? Positive 5. When you subtract 1 from negative 1, what do you get? Negative 2. What happens to the 6? It goes away. It's a constant, so it just dropped. It's plus. You don't write plus 0. So y prime is equal to 4x plus 5 over x squared.
So do we always have to put the negative exponent like so in the denominator line?
I mean, if I was just asking you to find the derivative of it, I wouldn't care if you left as a negative exponent.
Would you find a 5 over s?
No, because the negative and negative cancel each other out. Yeah. So the only reason I include the other way is because, again, if you're given multiple choice, you may not have a choice in how it's answered. So you need to be able to do either one. All right. So again, we want to write this as y is equal to 8x to the 1/2 power minus 1/3 x to the 6th plus 2 pi to the 5th. Again, what's going to happen to pi to the 5th? it's going to go away when you take the derivative. It does not become 10 pi to the fourth. So y prime, what's half of 8? 4. Subtract 1 from 1/2, we get negative 1/2. Minus, bring down 6, 1/3 of 6 is 2. Subtract 1 from 6, we get 5. And the only thing left to do is write that as 4 over the square root of x minus 2x to the fifth. This is the reason why. So I'm going to go back up to some of the previous notes we did. Remember doing this question and all the work we did for this question? Okay, using that limit as h approaches 0 of f of x plus h minus f of x over h. So these rules are why we do not have to do this. Okay? On the test, the only question you're going to have is a multiple choice question and just setting it up, not finishing it. Just replacing these two values. Okay? And simplifying maybe. Right? So that's the only question you're going to be asked about the limit notation of a derivative. Okay? Everything, because again, there's just no point. Right? It exists. We're glad it exists, but there are shortcuts, and we're going to use shortcuts. Horizontal tangent lines. Where on this graph are you going to have a horizontal tangent line? Yeah. What are those called, by the way? Yeah, local max, local mins are points of extrema. Yep. So, do you guys remember how to find local max and local mins? Well, you don't have to worry about doing it that way anymore. All right? Because if we take the derivative of a function and we know that everywhere we have a local max or local min, that we have a horizontal tangent line, what's the slope of a horizontal line? So if we take the derivative, what will we set the derivative equal to? 0, and that would help us find the local max and local mins. Now, it would only find the x values. It would not tell us if it's a local max or local min. What we'd have to do is plug them into the original function to see where they land. All right? And because, again, you guys spent so much time graphing polynomial functions, you know that if it's a third-degree polynomial, it has in behavior of going up, opposite directions. Okay? It has a maximum of 2 turns. If you know if it's a leading coefficient's positive, you know it's going up to the right, down to the left, which means that the rightmost point of extrema would be your local min. The left point of extrema would be your local max. All right? You do have to think graphically on some of these. Yeah. To be able to picture a graph based upon the information that, again, you spent so much time on in pre-cal and algebra 2, graphing functions. Right? So again, you need to remember in behavior. You need to remember how many possible turning points there are. You should be able to look at a polynomial function and go, all right, I know that in behavior. I know what the turn should look like. I don't need to know their exact values, but I do know if I'm given x to the fifth, my graph should look something like that. How many turning points, max turning points do I have? 1, 2, 3, 4. It's going up to the right because it's got a positive leading coefficient, down to the left because there's a negative leading coefficient.
All coming now.
All right. Now, we start out with a nice simple one. What kind of function do we have on number 3? It's a parabola, so we only have one vertex, really. All right, and we can actually use this to find the vertex by taking the derivative. So f prime of x is what? All right, and we set that derivative equal to 0. 0 is equal to 8x plus 7. So what is x? Negative 7 is equal to 8x, so x is negative 7 over 8. That is your x value for your vertex. Or do you remember your formula for finding vertex? Negative b over 2a. What's 2 times 4? 8. And negative b is negative 7, so negative 7 over 8. Yeah, you wonder where they got that formula from, right? Yeah, it came from calculus. All right, just to show you, if you remember ax squared plus bx plus c, what's the derivative of that? 2ax plus b, c's gone. And if we set that equal to 0, x is going to be negative b divided by 2a. So that's where that formula came from. Yeah. Normal lines. Now, there's just wasn't enough time to put normal lines on your test, but it may show up on the AP questions or the AP homework on the weekend. A normal line is perpendicular to a tangent line. So a normal line is perpendicular to a tangent line.
Right.
So what we want to do is we're going to find the tangent line. And then, do you guys remember how to find perpendicular slopes?
Was.
There you go. Yeah, negative reciprocal. Or opposite reciprocal, some people like to call it. Where you flip the fraction, change the sign. So we're going to find the, first we're going to find the coordinate. We know 3. What's the value for 3? 3 is at what? Negative 3. So there's our coordinate. All right. This would be, again, a tangent line. Okay. So this is tangent. A normal line would be perpendicular to that. So normal. Now, again, we still use the same coordinate, though, so 3, negative 3. Well, all I need now is the slope. So f prime of x would be 3x squared minus 8x plus 1. F prime of 3 would be 3 times 3 squared plus 8 times 3. Oh, minus plus 1. So that's going to give you 27 minus 24, which is 3, plus 1, that gives you 4. All right. Now, this right here is the slope of the tangent line. What's my perpendicular slope going to be? Negative 1/4. It's not a fraction, so make it a fraction by putting over 1, change the sign, flip the fraction. Perpendicular slopes, change the sign, flip the fraction. Now, I only have to put this in point slope form. I have my point, I have my slope. Y plus 3 is equal to negative 1/4 times x minus 3.
Numbers or whatever difference to negative 1. Like that.
So what?
What is that written next to negative 1?
Perpendicular slope?
What's that? Wait.
You guys don't know the symbol for perpendicular? M is symbol for slope?
No, it's a equal sign.
Wait, it's
That's a perpendicular.
at the same like
The slope. Yeah, and I know you guys haven't been in geometry for a while, but equal sign?
No, that's.
Is there anything else? Oh, look, there it is. Okay. Differentiability with piecewise functions. It's only a fifth of it, not half.
It's even worse.
I think you know how numbers work.
I think that there's a lot.
We need to kick him out of the office.
Go back.
We'll put you on hold.
All right. Now, when dealing with piecewise functions, in order to be differentiable, we must always check for continuity. If it is not continuous, we just say not differentiable and we're done. So, how do we know this is continuous? At -1, we plug it in. Does 5 times -1 squared plus 3 times -1 plus 2, does that equal -7 times -1 minus 3? Now 5 times -1 squared is just 5, plus 3 times -1 is just minus 3, so 5 minus 3 is 2, 2 plus 2 is 4. -7 times -1 is 7, 7 minus 3 is 4. So it is continuous. All right. For differentiability, since we know it's continuous, we can do the derivative of each part separately. So f prime of x is going to be 10x plus 3 and -7. At x is less than -1, x is greater than or equal to -1. All right. Now, in order for this to be differentiable, we must approach the same value as well. So, does 10 times -1 plus 3 equal -7?
Yep.
Yeah, that also works. So the answer is yes, it is differentiable. Right? If we had gotten different values, that means we would have an abrupt change in the rate of change. So that would cause a sharp corner, in which we know it's not differentiable if it is not smooth. So what this does is allow a smooth transition between these two functions. Now, this question will be on your test. Right? We are going to do the same thing we just did. We have a continuous side. Okay, so we take 3 and plug it in. So it's 3 squared minus a times 3 plus 2 and set that equal to 3 plus b. So we get 9 minus 3a plus 2 equals 3 plus b. So we have 11 minus 3a is equal to 3 plus b, or 8 minus 3a equals b. Now this is where most people made mistakes. When you do the derivative, what's the derivative of b? 0. B is a constant. So b will go away. Right? So f prime of x would be 2x minus a at x is less than 3 and 1 at x is greater than or equal to 3. So if we plug in 3, that means 2 times 3 minus a is equal to 1. 6 minus a is equal to 1. And what minus 6 is 1? That means we can plug that in here. 8 minus 15 is equal to b. That means b is equal to -7. That is it for the notes today.